Dear students, now we are going to see the subject linear integrated circuit. Subject code is EC3451. Under that, the topic is switches for digital to analog converter and sample and hold circuit. So switches for analog digital to analog converter and sample and hold circuit. On completion of this, the students will be able to explain the different types of switches used in digital to analog converters. Switches control the signal flow by closing and opening. The switches are operated by digital signals. Totem pole MOSFET switch. The totem pole MOSFET switch is connected in series with the resistor R2R network. It operates with zero offset voltage. When the switch is low, the inherent offset voltage of bipolar transistor limit its use as a switch. To overcome this problem, MOSFET switch is preferred. The circuit diagram of totem pole MOSFET switch is shown in figure. The RS flip-flop is used to hold one bit of digital information of binary word. The output of flip-flop Q and Q complement derive the gate of MOSFET M1 and M2. The output Q and Q complement is called complementary output. When the bit line is high, make S equal to 1 and R equal to 0. The corresponding output Q equal to 1 and Q bar equal to 0. As for this transistor, M1 is on and connecting the resistor R to the reference voltage minus VR. When the bit line is low, make S equal to 0 and R equal to 1. The corresponding output Q equal to 0 and Q complement equal to 1. As for this transistor, M2 become on and M1 become off, connecting the resistor R to the ground terminal. CMOS inverter as a switch. The inverter ladder digital to analog converter are fabricated using monolithic CMOS technology. The switches used in this digital to analog converters are realized with CMOS transistor. The circuit consists of CMOS inverter connected with an op-amp. It acts as a buffer. The circuit diagram of CMOS switches shown in figure. The buffer drives the resistor R with low input output impedance. When the complement of the bit line Q is low, the transistor M1 is on, connecting VR to the non-inverting input of op-amp, which drive the high resistance. When complement of bit line Q bar is high, the transistor M2 become on and the resistor R should be grounded. Switches using CMOS transmission gate. In a single MOS transistor switch, if the transistor is NMOS, it can pass a voltage less than VR by one threshold voltage. If the transistor is PMOS, it can pass a minimum voltage of one threshold voltage. To overcome the above limitation, the transmission gate is preferred. The transmission gate is a parallel connection of PMOS and NMOS transistors. When the bit line is high, both the transistors Mn and Mp is on. It offers a low resistance over the entire range of bit line voltage. When both the bit line is low, both transistor Mn and Mp are off and the signal transmission is prevented. The P-channel FET offers a low resistance over the upper portion and the N-channel offers a low resistance over the lower portion of that signal. High-speed sample and hold circuit. Analog to digital converters are used to convert the naturally generated signal into a digital format. The analog signal is first sampled using sample and hold circuit before applying to analog to digital converters. ADC circuit conversion process stability is improved by using sample and hold circuit. Sampling process convert the continuous time domain signal into discrete time signal called pulse amplitude modulated signal. These samples are then applied to ADC for conversion. The ADC process satisfies the following conditions. First one, the sample and hold circuit is used to sample an analog signal for a short period of time and hold the analog voltage constant while the conversion takes place. The sampling interval must be greater than or equal to the propagation delay Tb of the A to D converter, that is Ts is greater than Tp. Second one, the sampling must be done as per the Nyquist sampling theorem. The signal must be sampled and recovered from its sample if the sampling is done by Sampling frequency is greater than or equal to twice the maximum frequency of the analog signal. So Fs is the sampling frequency. Performance parameters, acquisition time TAQ, the time required to get an accurate sample after the switch is closed. The quality of sample and hold circuit depend on its acquisition time. Drop time, this is defined as the rate at which the output voltage decreases in the hold condition. Aperture time TAP, it is the time required for the switch to open. Since the switch is a transistor switch, there is a short time before it appear open, and this time affects the hold circuit capacitor. Quantization, it is the process of mapping or splitting an analog signal into several equivalent discrete level or continuous input value or converted into discrete or the discontinuous output values. Aperture uncertainty, del TAP, or aperture jitter. It represents the variation in aperture time from sample to sample. If TAP is compensated by advancing the hold command by TAP, then change in aperture time del TAP establishes a timing error. The jitter result del V0 equal to dV1 by dt del TAP. The above equation indicating the actual sampled waveform can be viewed as the sum of ideally sampled waveform and a noise component. Hold mode setting time TS. After established hold command, it takes some time to settle within a specified error band such as 1% or 0.1% or 0.01%. This is known as hold mode setting time. Hold step del V0 or the pedestal error or a sample to hold offset. Because of parasitic switch capacitance, when the circuit is switched to the hold mode, there is a unwanted charge transfer between the switch driver and the capacitance, causing a change in voltage across the capacitance. This change del V0 is referred as hold step. Feed through. In the hold mode, because of state capacitance across the switch, there is a AC coupling between the output and input voltage. This AC coupling causes the output voltage to vary with variation in the input voltage. This is referred as feed through. The feed through rejection ratio is given by FRR is equal to 20 log del V0 by del VI. Circuit description. The operation of sample and hold circuit has two modes. One is sample mode and the second one is hold mode. When the sample and hold pulse is received, the circuit swings V0 towards the VI and forces the output to follow the track with input for the remainder of the pulse. This is called a track or a sample mode. After sample hold pulse is removed, the circuit holds the output at the value of input, and this instant of pulse deactivation is called hold mode. The circuit sample the input signal when the sample hold command is high and hold the sample signal when the sample hold command is low. The high speed sample and hold circuit is shown in figure. So this figure shows the MOS transistor M is an analog switch which alternately connect and disconnect the capacitor C to the output of op-amp A1. When the transistor M is off, the diode D1 and D2 are used to prevent the op-amp A1 into the saturation. The diode D1 and D2 are inverse and parallelly connected. The output of op-amp OA1 is given by V0 dash of T equal to VA of T minus 0.7 volt if VA is less than V0 of T, and V0 dash of T equal to VA of T plus 0.7 volt if VA of T is greater than V0 of T. When the transistor M is on, both the op-amp A1 and A2 act as a voltage follower. The control voltage Vs of the transistor gate terminal is used to turn on and off the transistor alternately. The voltage Vs is to be higher than the threshold voltage of the FET. When the input voltage Vi is larger than capacitor voltage Vc and transistor M is off, it rapidly charges to a level of Vi. The instant M switches on. Similarly, if Vc is greater than Vi, when the transistor becomes on, then capacitor discharges to the level of input voltage. When the transistor M is off, the gate source voltage, reverse leakage current of FET, and the input bias current of op-amp A2 are effective in discharging a capacitor. By using this capacitor, the sampled voltage is held constant until the next sampling instant or acquisition time get occurred. So the capacitor voltage waveform is shown in figure. So initially the acquisition time, the variation is obtained from 0 to peak, and it remains approximately constant during the whole time. The capacitor C is charged via the FET channel resistance during the sampling time T1. The capacitor charges to 0.993 of input voltage. The charging time T1 must be equal to 5R. While during whole time T2, the capacitor partially discharges. Advantages used to reduce the crosstalk in multiplexer. Synchronization can be achieved by sampling signal from all the channel at the same time, while conversion time of A to D converter is used to hold the constant analog input voltage. LS398 sample and hold IC. LS398 is a bipolar field effect transistor sample and hold IC. The transistors are manufactured by combining BJT and FET in one single silicon substrate. The op-amp A1 and A2 act as a voltage follower. The external capacitor is sandwiched between OA1 and OA2. The connection of LS398 block diagram is shown in figure. The op-amp A3 is a buffer amplifier that drives the switch according to the sampling pulse applied between the inverting and non-inverting terminal. The amplitude of sampling voltage is limited to plus 5 volt. LS398 is a commercial sample and hold IC used in military application in the range of minus 55 degrees centigrade to 125 degrees centigrade, and industrial application in the range of minus 25 degrees centigrade to 85 degrees centigrade. The maximum value of signal to noise ratio of 8-bit ADC with an input range of 10 volts is 49.8 dB. Thank you.